compound, increase and decrease. So this is all to do with percentages again. Now, let's explain this first of all. So there's simple interest and there's compound interest. Now, the easiest way to explain it in simple terms is to think about a bank account and adding interest to it. So if we were dealing with a simple interest situation, then at the end of the year you would take your interest out and you would spend it. So each year you would have the same amount in your bank account, and therefore at the end of each year you get the same amount of interest, assuming the rates haven't changed, obviously. Whereas with compound interest, at the end of the first year you leave the money, the extra money that you've earned as interest in there. So that means when you start the second year, you've actually got more money to start with already in there. So you're going to get more interest at the end and so on. And that's how it's going to compound. So we're going to look first of all at how we figure this out the long way round so that you can understand where the short way round comes. Okay. So let's say that we invested £100. We're going to get 5% a year in interest, and we're going to do that for 3 years. So at the beginning of the first year, we've got £100. At the end of the first year, we will have 5% more. So remember, we've looked at how to do this on the calculator. If we want 5% more, that means we're going to have 105% at the end of the year. And 105% as a decimal looks like 1.05. So if we do 1.05 times our 100, we're going to get £105. So that's how much we've got at the end of year 1. So now we're starting year 2 with a new amount. We've got 105 this time. But the percentage rate hasn't started. So if you like, this is our new 100%. We're adding on 5%. So we're still going to be using the same multiplier here, but with a different number. So for year 2, it's going to be 1.05 times 105 this time. And I'll just do that quickly on the calculator. 1.05 times 105 is going to give us £110.25. Okay, so we're not changing the rate. So this is our new, so let's just write that in. So that's at the end of year 2. This is our new amount in the bank. It's going to be 5% bigger, so that's our new 100%. So we're still multiplying by this 1.05. So that's 1.05 times £110.25. And if we put that into the calculator, so I'm going to times my answer by 1.05. And that's going to give us £115.76 with the odd 25 bit on the end there. Okay. So now let's look at how we can take this long way and turn it into a much shorter, more efficient way. So if we look and follow through this process, what do we do? So, sorry, that's the end of year 3. Let's just write that in first of all. So we started with 100. We multiplied it by 1.05, and that turned into this. Then we took the answer to that question and multiplied that by 1.05. Then we took the answer to that and multiplied it by 1.05. Now what you can notice here is that we're repeatedly multiplying by this number. So a much more efficient way of looking at this and doing this is to see that we've got 1.05 to the power of 3, because we're multiplying by it 3 times. Sorry, that 3 is not very clear. So this brings us to the short way to put it into the calculator. So we have our initial amount here, we have what I call our multiplier here. And we got that by adding the percentage onto 100% and turning it into a decimal. And then this up here, the indices, is the number of years in this case. Sometimes it's some other kind of time period. It might be hours or days or whatever it is, but that it's going to be some form of time that you're going to use up here. So the much quicker way to have done all of this would simply have been to put 100 times 1.03 cubed in this case. Okay, and you can see that we get the same answer, £115, 76 pence and 25 little bits there. Okay. Excuse me for my voice today. Okay, so we're now going to do a couple more examples. So here we have a sort of classic type of question. They want us to work out the value of the item or money that we've got after 3 years. So we're starting with 3,450 and it's an 8% per annum. That's what that stands for, per year. And doing compound interest. So now with our short way, we know we take the original value, the 3,450, and we're going to multiply it by our multiplier. So let's think about it. So 8% plus 100% is 108%. And if we turn that into a decimal, we get 1.08. So that's our multiplier this time. And it's 3 years, so it's going to be to the power of 3. So we put that into the calculator. We've got 3450 times 1.08 to the power of 3, and that's giving us 4346.0064, and since this is money, we would typically round that to the nearest penny. So 4,346 and just the 1 penny there. Okay, now sometimes things decrease instead of increase. So we've got an example here. We've injected 14 millilitres of a drug at 12 noon, and it's going to fall at a rate of 8.5% per hour, and we need to work out how much is left in the patient at 5 p.m. So 8.5% is our rate, but this time we're starting with 100% and we're going down by 8.5%. So that's going to leave us with 91.5%. And as a decimal, that's going to look at like 0.915. So the rest of it is identical. It's just that if it's a decreasing situation, you take it away from the 100 instead of adding it on if it's an increase. So we've got our original number of 40. We're still multiplying, and it's by 0.915. It's because we're multiplying by something less than 1 that's going to make it go down. So we're not dividing, it's always multiplying. And this time we've got to work out how many periods of time. So it's per hour. So how many hours between 12 and 5? 5. So that means that we're going to do it to the power of 5 this time. So on the calculator, here we're going to start with 40 times 0.915 to the power of 5. Press equals, and we find the answer is 25.65461264. So I've rounded it to 2 decimal places. So 25.65 millilitres is our answer there. Okay, so just to recap, if it's increasing, we add it to 100% and turn it into a decimal. And then this is the number of years or time periods. If it's a decreasing situation, we take it away from 100%, turn it into the decimal. We still multiply by that, and the power in this case was hours rather than years, but it's always some time period.